Shall we begin?
Sure.
Okay.
So 1 and 2 true. 3.
Oh wow. 21 questions. Going bigger. Okay. Status quo.
That's going to be the null hypothesis, right?
Yep.
Which hypothesis involves equality? Isn't that the null hypothesis as well?
Yep. This one we assume to be true.
Okay.
Looks good, looks good. P-values, probability of obtaining some circularly some string observe 5. When computing this probability, which hypothesis you assume? Aren't we still assuming the null hypothesis is true?
Yep.
Yes.
Okay, cool. So everything was null until 6. Still, whatever. Suppose the null hypothesis is equals 10. Use this information. Okay, which of the following represents an alternative hypothesis for a two-tailed test? Would it be not equal to?
Yes.
What was that reading?
What?
This is a two-tailed test. Was that in the reading?
Yes. Well, kind of. It's on page 5 under the null and alternative hypotheses. And it's the first example of mu is not equal to 98.6.
Yeah.
The left-tailed test would be less than?
U is less than the number. I agree.
I hate always doing it. I always have to use my left hand and be like...
I know.
U is less.
Right-tailed, it would be greater. U is great, so it's chomping at the U.
Okay.
The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Use this information. Which relationship would result in failing or reject the null hypothesis?
P-value greater than.
Yeah, if P is higher than A.
Yeah.
Why did they put Z?
I don't know. To see if you're really paying attention to what you're picking, or if you're picking P-values greater.
Greater than my Z score. Because alpha is the area, right? When you plug in the Z score? Okay, that's what I thought.
Yeah.
Which relationship would result in rejecting?
What about...
So alpha is greater than P. That's when you reject the null.
Yep.
And then 10 would be the... Would it be less than?
Yeah, 10 should be p-values less than alpha.
So 9, the mouth should be chomping at the p-value, and in 10 it should be chomping at the A.
Yeah.
That's how I remember less than and greater than in middle school.
Yeah.
As dumb as that is. Anyway, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was 15 hundo. They are concerned that the true mean is actually higher than this. Okay, that's easy. Use this information. Which of the following could be appropriate alternative hypothesis? All right, well, they think it's going to be higher, so the average claim is greater than 1,500, correct?
Correct.
Yes.
All right. So C. Which of the following would be the appropriate null hypothesis? The average claim amount is equal to?
Yeah. So it says the average claim amount was 1,500, so that's assumed to be true for the null.
Yeah. All right, we're good there. All right. The insurance company. Any questions before we move on?
Nope.
Okay, cool. The insurance company randomly selects n equals 40 claims and calculates the sample mean of X bar being 1,650. Uses this information. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes.
Yes.
It's above 30, so we can assume it's a large and it's going to be normal. Isn't this the
Central.
Central limit, yeah.
Yeah.
Between us, that's what was on the test, right?
Yep, pretty much.
Okay, which of the following is a test statistic as defined in this lesson? Is that X bar?
I believe it's Z.
Is it Z?
Yeah, that's that weird one on the assignment. I'm going to go double check, but I believe that's the calculation it asks for.
I think you're right. I can't remember, though.
Write down the formula for computing a test statistic for the hypothesis test for a single mean when sigma is known. It's the Z-score. Excuse me. The Z-score formula.
Oh, and okay, because I'm seeing it here on step 4. Step 4. Z. This is our Z-score. Okay. Test statistic, Z-score. The historical mean of sales receipts at a grocery store is 150 with standard deviation of 40. The store manager suspects that the average has decreased. Ooh. She sets up a hypothesis test with the following hypothesis. Okay. So we're good. She will use a level of significance alpha of 0.05. She then takes a simple random sample of 36. She's good on that. Receipts from her store and computes X bar is 144. So just plug in the numbers. What is the Z-score? Gotta find a calculator now.
We gotta get the applet back up.
Yeah, that'll be fun to dig for.
Alright, so we have 144 minus 150 over the deviation 40 divided by square root of 36.
Wait, was it 150 minus 144? Am I doing this backwards?
It's going to be 144 minus
144. Yeah.
Yeah.
Okay.
Is the freaking applet in like lesson 2?
Yeah, lesson 2 or lesson 5 technically, week 2.
Okay.
The link's still up by the exam stuff as well. If you just click on that, it's really easy to get to.
Oh,
Oh yeah, that.
good thinking.
So let's see. So we're gonna do less than that Z-score.
So left side.
Yeah. What did y'all get for the Z-score on that one?
I got 0.9, negative 0.9.
Yeah, that's what I got too.
All right. Sweet.
So we plug that in. We take the area to the left of that Z-score because we're looking for the less than probability.
Mm-hmm.
So is that middle and left side?
No, it's just the left side of that Z-score.
Okay.
Because the Z-score is negative.
Yeah.
Okay, that's what it was.
If it was a positive Z-score, it'd be in the middle, I believe, as well as the far left.
Okay. That makes more sense.
So when we do the equation then, the alpha doesn't even play a part in it?
Well, not in this question for
Just
16.
for the p-value, right?
It's for 18.
Is it?
Yeah. Well, if the p is low, you'll reject the null, and since we're comparing it to 0.05.
Gotcha.
So wait, let's
Okay.
get the Z-score and stuff first.
So for 17, did you calculate that yet?
No.
Is the p-value just the area?
Yeah, the area.
Okay. I'm just
So
trying.
I got 0.184. Let me know if y'all get the same thing.
Yeah, it checks out with me.
Yep, I got it.
So the p is not low, so we fail to reject the null hypothesis.
I have the noisiest neighbors ever.
Dude, last night they had like a party or something. They were yelling like 4 doors down from us, and we could hear them. Like, I don't think people have lived in close quarters before, so they don't know how to act.
Exactly.
Okay. These are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Whoa.
It should be a type 1.
Okay. Type 1, reject the null.
Yes.
When the null is true. Type 1. Researcher decided that instead of using a level of significance of 0.05, he will use a 0.01, which of the following will be true. Is this based off what we had before? Okay, no, that's not part of the question. Sorry. Wouldn't the probability...
Decrease?
So is it C?
I forgot what, I can't find what page it was on.
Because if you have a lower level of significance, then it's going to be a lot easier to pass the data.
Yeah.
Right?
So let's say using the level of significance of alpha equals 0.05. You will use alpha equals 0.01. Which of the following will be true?
So it says in the reading, we do not want to commit type 1 errors, so why not choose a very small number for A? If we choose A to be so small that we rarely commit a type 1 error, what would happen to the probability of committing a type 2 error? And then it talks about it. I don't know if you guys know where that's at. It's right under the little table.
Where was that at?
Kind of just screws everything up. Right under the table.
Larger.
It kind of just throws everything off, really. Yeah, type 1 will go away, but type 2 is going to pop up really high, I guess.
So would it be D then?
I think so. If you decrease the number, you have a better chance of having a p-value higher than your alpha, and that would make your type 2 errors increase.
Okay.
Okay, and then 0.05, compute the probability of committing a type 1 error.
It's just 0.05, isn't it?
That's what I'm thinking. I'm just making sure there's nothing else in the reading.
On our homework, we have like a very similar question.
That is true.
Or not homework, there. Whatchamacallit says, if the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error? And the answer is 1 in 100 or 1% or 0.01.
Because this is just 5%, so do we just want to do 0.050?
Yeah. We all agree on that one?
Yes.
I mean, it makes sense. If it was in the homework and it's asking the same question, different number. All right, you want me to go through them real quick?
Let's do it.
Okay, 3 is the null hypothesis. 4 is also the null. 5 is also the null. Okay, yeah. 6 is U is the equal sign with the slash through it. 7 is U is less than 10. 8 is U is greater than 10. 9 is the p-value is greater than alpha. 10 is p-value is less than alpha. 11 is the average claim amount is greater than 1,500. 12 is the average claim amount is equal to 1,500. 13 is yes. 14 is central limit theorem. 15 is z. 16 is negative 0.900. We good so far?
Mm-hmm.
Yes.
17 is 0.184. 18 is fail to reject. 19 is type 1. 20 is the probability of type 2 error will increase. And 21 is 0.050. Any questions?
No.
Let's see what happens. A plus. Woo.
Woohoo!
Sweet. So that's not too bad as of right now. We're all pretty much on the same page.
Yeah. I think just because we started a new unit, we're going to kind of break things down a little bit again before we dive in deep.
Yeah.
Agree. Cool.
All right. Well, I guess we'll meet up Tuesday again at 6.
Sounds good.
That's good.
All right. We'll see you guys then.
Yeah.
Thanks. Bye, guys.
Bye.